In this video, we talk about basic ARMA models. Note, while a white noise process epsilon t appears to be totally unspectacular, if not even boring, it nevertheless allows us to capture a variety of predictability patterns in any stationary variable x. Also note, without loss of generality, but to simplify the notation, we are going to assume that our stationary process x is in fact demeaned. A demeaned process has an unconditional mean of 0, which we write as the expectation of xt equals 0. So in empirical work, you demean a stationary time series by subtracting from each observation the sample mean. So let's start. The most important and at the same time the most basic ARMA models are the AR1 and the MA1 model. The AR1 model for a demeaned process x has the following data generating process that you take from the next equation, where x0 and phi and sigma square epsilon are known real constants. It's good practice to let the starting value coincide with the unconditional mean, here x0 equals 0. Now similarly, if xt follows a mean 0 ARP model, its data generating process is given as in the next equation, with epsilon t being a white noise process. The second most basic ARMA model is the MA1 model. If a demeaned xt follows a MA1 process, its data generating process is given by the next equation. Now, analogously, an MAQ process has the following data generating process, which I summarize in that equation here, with epsilon t being, again, a white noise process. Now, so the MA process is basically a weighted average of past forecast errors. In contrast, an AR process is a weighted average of past forecasts. Now, not surprisingly, any ARMA PQ model is simply the combination of an ARP model and a MAQ model, as I'm summarizing here in the next equation. And all the coefficients from phi1 to phi p and theta1 to theta q are real valued constants, which in order to satisfy stationarity for xt might have to fulfill special constraints. And last not least, the epsilon t is again, you guess right, a white noise process. Now as a final remark, assume you want to model a zero mean return series RT according to an ARMA 2-3 model. Please make sure you understand why its data generating process looks the way I'm just showing you in the next 3 equations.